is our class number 3 and the topic is algebra. Algebra is a branch of mathematics that deals with symbolic relations. These relations might stand for equations, such as in the first two examples, where the first equation is one of the simplest types that we have, and the second equation has many types of relations between these values that we don't know. And the third is an expression that depends on the value of x. This type of expression is also called a function. The algebraic operation between symbols follows the same standards as we had in the arithmetic. So here we would have a plus 3b plus, then just multiply 15c plus 10b. B might combine with another term that has b. So we will have a plus 13b plus 15c. In the other example, a squared might be combined. So we would have 2a squared plus a plus b plus c, because these can't combine between themselves, or with a squared plus 52. The multiplication between symbols follows the same standards in this case, where we have x times x squared is as if we had twice 2 squared, so it's x to the third. And in this case, just remember to cross multiply each term with each term. So the product will be x to the third plus negative 7x squared plus xy plus negative 7y, which for sure will give us, just need to find the sinus, x to the third minus 7x squared plus xy minus 7y. These are important products that you might have already seen during your school life. But have you imagined how good they would be to solve situations like this? 19 squared is the second product. So 19 is nothing more than 20 minus 1 squared. So 400, the first squared, minus twice the first term times the second, plus the second squared, which gives us 361. The other one, 38 times 42, could be thought as 40 minus 2 times 40 plus 2, which is 1600 minus 4, which is 1596. The division in this case, just like the previous case in the multiplication, happens just like we had numbers. So x to the third times x divided by 2x. We can cut off the x since x is not 0. So the result is x to the third divided by 2. This other expression, you may factor out the y, because you have y in every term. So it's exactly as doing this, x squared plus 2xy, plus x squared y divided by y times x plus 1. This results in this expression, but this is not a perfect square. So the solution would be trying to produce this perfect square. This way, x squared plus 2xy, we should have a plus 1 now. Plus 1 minus 1, so you should sum and subtract. I'm going to just explain you why to do this. Plus x squared y. Everything is divided by the same denominator, x plus 1. So this and this. The first is a perfect square divided by the root. So the result is x plus 1, because this could have been written like this. And the other part is the remainder. We should change the signal here. Divided by the divisor. But usually, the algebra problems in GMAT won't be like this. Let's say pure math. You're, you're supposed to translate problems, such as like this one. Margaret has two more than 12 books in an island. Together they have 29 books. How many books does Margaret have? So Margaret has two more than twice the quantity of books that Alan has. They have together 29 books. So you can write the quantity of books that Margaret has equals 29. So 3a equals 27. A is 9. So Margaret is twice 9 plus 2, 20. So she has 20 books. Ellen has three more than thrice than Brenda. This is a little bit complicated, but three more than thrice, three times. Together, they have 19 candies. So A plus B equals 19. How many candies does Ellen have? You can just substitute. So 3b plus 3 plus b equals 19. So 4b equals 19 minus 3, which is 16. So b is 4. Therefore, a is 15. So Ellen has 15 candies. The aging problem is a little bit different. Soraya is 3 times as old as Tonya. In 20 years, so Soraya will be 20 years older. She will be twice as old as Tonya. What's the age of Tonya in 20 years as well? You should always remember to do this. If you do this, there is no problem. You're never failing. So F equals twice t plus 20, because we should subtract this 20 when we put it into the other number. Then we have this equation and this equation. Now we can find the age of Tonya. So 3t equals twice t plus 20. Tonya is 20. Soraya now is 3 times as old as Tonya. So Soraya is 60. So when Tonya was born 20 years ago, Soraya was 40. This is a problem that will happen in different situations, but always remember to compute time in the future and time in the past for all members, unless stated otherwise in the question. There's another type of equation that may seem awkward, but it's just an equation with integer constraints. This example. Mel went to the market and she bought all apples and bananas. Each apple costs 25 cents and each banana costs 11. So I could write this. She spent $2.24 at the market. How many apples and bananas did Mel purchase? This problem, in the first glance, might seem a lot awkward because we have A and B and we don't have any other equation. How to solve? Sometimes it's useful to try to locate the, the multiples. So you can manipulate just like this. You have to find whether it, it's easier to locate a multiple of 25 or 11. Supposedly it's 25, but I'm going to do it with 11 to show you how easier it could be. Just multiply it by 100. Then I'm going to write like this: 11b equals, then I should know that on this side I should have a multiple of 11. And a multiple of 11 might be found like this. For instance, a random number, 5, 2, 7. Just sum. The sum greater than 11, 12. 12 minus 11, 1. This is not 1, so this is not multiple of 11. But if I had this, then this property would happen. Would just say this is a multiple of 11. And here you will subtract. So since I have to have at least one apple, so reducing one apple, 199, 1 plus 9, 10, not this one. 174, 1 plus 4, 5, not this one. So it's much easier to check than we thought before. The other one, 151, 2, not the middle, it's not matching up until now. The next one, 124, 5, not this one. So 8 is 1, 2, 3, 4, now 5. 99 is a multiple. So just check if that's the only possible answer. I will reduce a few more times, 74, 51, and 24. Wow, we didn't find any other multiple. So I have 5 apples and 9 bananas. So 5 plus 9, 14. So she bought 14 pieces of fruit. Sometimes you have an unnecessary value to connect things. So x is 3a minus 10, and y is twice a minus 8. What is y when x equals y? That's the equality, so they are equal, supposedly, so a equals 2. So we want to know the value of y, so please don't mark letter A. Y would be twice a, 4 minus 8 minus 4. Letter D, y equals, in this case, twice 2 minus 8, which is 4. Okay? Well, that's it. That's the end of this class. So see you next class, class number 4.